Hello everyone, and welcome to the State Science Day project, How Does Water Salinity Affect the Plant's Growth? By Likit Tanishk. So, first question, what is water salinity? Water salinity refers to the amount of salt dissolved in water. Imagine if you tasted seawater, it would taste salty. That saltiness comes from dissolved salt in water, but in smaller amounts. Salinity is measured in parts per thousand, which tells you how much salt is in the water compared to total amount of water. Why is seawater salty? Because over time, rainwater carries dissolved minerals from land into rivers and then flow into the ocean. These minerals include salts like NaCl, sodium chloride, magnesium chloride, and potassium chloride. When the water evaporates from the ocean, it leaves the salt behind, so the ocean becomes saltier. Next, the hypothesis. If we expose plants to water with different levels of salt, I predict that higher salt levels would have a negative impact on their growth. My hypothesis is that increased salinity in the water could make it difficult for the plants to absorb the water and nutrients they need from the soil. This might result in slower growth, shorter height, and fewer leaves compared to plants receiving water with lower salt levels. On the other hand, I expect that plants watered with less salty water would show healthier growth, potentially being taller with more leaves and a fuller appearance. I believe this experiment would show how salt in water can affect plant growth and provide farmers the right machine for farming, which is important for our knowledge about taking care of plants and growing things successfully. My engineering goals were creating salt-tolerant plants varieties. I think genetically manipulating the plant's genes or testing different plant varieties that are more resistant to high salinity levels. So, what were my procedures? My procedures were selecting a plant suitable for experiment, taking a common but simple species of plant to ensure easy and comparable results. That means the plants that have more stress, like the African violet, the spider plant, and the Boston fern. Second, dividing plants into high salinity, low salinity, and moderate salinity, and regular salinity. Take 3 plants and decide them into high salinity, low salinity, and moderate salinity, with everyone receiving equal normal water and sunlight. So, for example, salinity level 1 would be spider plant, and salinity level 2 would be the Boston fern, and salinity level 3 would be the African violet. Measuring growth. Regularly measuring growth with a ruler or measuring tape for each plant, or checking the leaf count of each plant to ensure reliable results. Fourth, observing any visual symptoms, documenting any symptoms of stress in plants. For example, the crown rot, which builds up salt in the root of the African violet. Fifth, recording water usage. Measure and record the same usage of water in each plant during the month of experimentation. Number 6, checking the weather conditions, making sure it's sunny, and not making sure the experiment takes place in a rainy day. Exposure. The experiment took place between November 25th and December, where not most of the days were rainy, which was lucky for me. By this method, I could determine how salinity influences plant growth and draw conclusions. Before we move on to data analysis, I wanted to tell how does my project connect to real world. The above project on water salinity effect on plant growth addresses a real world issue. In regions where water salinity is high, such as coastal areas, or arid regions where saline groundwater traditional crops struggle to thrive due to the effects of salt on plant growth. Then I wanted to show how different tolerance levels are beneficial to differing locations. By studying plants' tolerance to salt, researchers can also develop salt-tolerant plant varieties that are better adapted to grow in saline conditions. Next, data analysis. Data analysis, the variables were plant growth metrics were including height, leaf count across different salinity levels, and then the dependent variables were the leaf count that depended on the height and stress. So next, trend identification using linear regression analysis. So upon analyzing the data and plotting them in Python with my data set, a consistent trend would emerge as salinity levels increase, both plant and height and leaf count progressively decreased, and statistical analysis was determined. And in conclusion, our data analysis provides robust evidence of the detrimental effects of water salinity on plant growth. Next was the graph Python created when I inputted the data that I jotted down in a logbook. And this is this other graph it gave to. Results. So my results were, after analyzing the data from the experiment consisting of 3 different salinity levels, were presented in the table below, or the table I'll show at the end of the video. After examining the data and graphing it, a clear trend emerges that as salinity levels increase, both plant height and leaf count progressively decreases. If we can see over here. And our conclusion in wrapping up this project, I have uncovered important insights to a global issue, water salinity, and the hypothesis guided my project. And our engineering goals proposed innovative solutions, and the data analysis defined experimental design, and the bibliography was a book from Smith J.A., Plant Growth and Soil Salinity, and a website, Understanding the Impact of Salinity on Plants. And last but not least, we have real-life use cases. How does water salinity affect the plant's growth? Real-life use cases. First use case is agricultural practice, and second is environmental remediation, urban landscaping, aquaculture and hydroponics, water management policies, educational outreach. Last is my quad chart for the State Science Day. And once I go to my final data research plan, as you can see here, this is the data from week 1, this is the data from week 2, this is the data from week 3, this is the data from the 4th book, and this is the data for regular salinity, and all of this is noted in the logbook. And these are the spider plants. These are the stress I have observed, as wilting leaves, yellowing leaves, and also the data is noted down in 3 times per week. That means 1, 2, 3. This all is 1 day, and then this all is 1 time in a week, and this all is 1 time in a week. And this was the graphs here. So that's all for this video. Thank you for watching, and my name is Luka Tanish, grade 8 from Mason Middle School.